In this video, we're going to walk through what really is video understanding and how does it differ from basic image understanding. What you'll take away from this video is the knowledge of building out a sophisticated semantic video understanding search application that is able to understand the context of your query and not just the subjects of the frames in the video that you're looking for. So if we think about video understanding, we have to first process the video. And in a video, you can think of it as really just three components. You have the visual frames, you have the audio tracks, and you have metadata that kind of captures a large portion of the video itself. And typically videos have varying frame rates, 60 frames per second, 30 frames per second. It's entirely dependent on your capture source. And then you have the audio tracks, right? You have people, you have music, you have sound effects, etc. And so really what you want to think about is how do we actually process the frames of the video? And the frames you can think of as they're just still images, right? We have a video, maybe it's 60 frames per second. Every 1/10 of a second is a frame, or every 1/5 of a second is a frame, so on and so forth. And so typically a lot of these frames are redundant. They're capturing kind of the same image. And so we want to actually sample the frames. This is just one method of processing videos. And so maybe we want to sample every second, right? If it's a 60 frame per second video, or every half a second, etc. And so there's pros and cons for this. A pro is it's very simple, very easy to process every nth frame, but we can potentially miss some scenes, right? And so it doesn't really understand, hey, the first frame is actually very different than the last frame within this sample, but we're only capturing one of those frames because it's within the sampling interval. So think of it as a uniform strategy for extracting frames. There's also keyframe detection. And so that's just really capturing, hey, what are the visual changes or kind of peak action moments within a sequence of frames, right? And so this is really understanding how the frames transition across the sequence. And it is potentially using an ML model. We actually have explored this model called AutoShot. Take a look at what that is. It's a state-of-the-art model that's actually able to capture the shot boundary of the actual frames. And so this is useful because it allows you to split a video by scene. And it really is just under the hood, what is the pixel transition difference? What is the we have frame A, we have frame B. What is the delta of pixels between them? And so we can reasonably infer that that is a scene transition. And so we have keyframe detection, and scene-based transition is kind of the same thing, except keyframe is more so oriented around particular actions, activities, etc. Scene-based is more around, hey, are these scenes different, right? And there's a bunch of different methods for determining scene-based transitions or distinctions. The AutoShot model is one. You can also do what's called semantic deduplication, which is effectively we take the embeddings of all of these frames, we compare the embeddings of these frames, and if it exceeds a certain threshold, then we can infer, hey, this is a new frame because of that distance in semantic space. So again, these have trade-offs. Each of these are different frame extraction techniques. But then once we think about, okay, we have the frames, then we can extract the embeddings from the frames. And we have a different video in the library of videos that we've done enablement on, in which we've talked through the SIGLIP embedding model. And SIGLIP is an embedding model that Google has open sourced, and we actually have it hosted on the MixPeak Studio. And if you wanted to use the image extractor, you could use SIGLIP. But if you wanted to use a video understanding model, well, there's trade-offs for using both. Video understanding is, as you can understand, a lot more expensive, computationally intense, but it actually is able to capture the context between frames. So again, frame level is, hey, let's embed all of these frames using the different extraction techniques, sampling, keyframe detection, scene-based frame extraction, right? And so we can extract the frames and treat them as images, or we can treat the sequence of frames as a single video. We'll get into how that works under the hood in a bit, but just know there are trade-offs for doing these different frame level versus video level embedding encoding, right? Frame level doesn't understand frame A versus frame B. It doesn't understand, hey, this search might traverse both of them. There's no temporal understanding of these frames across the sequence. So that's where video comes in. And the video embedding models, we actually have one that we've open sourced. Video embedding models typically understand, hey, these frames capture similar contents. Let's treat them as a single embedding. And so as you can understand, there's different video search capabilities. If you have, let's say, a person dribbling a basketball, well, a frame would just say, hey, that's a person running, has a basketball. But what is dribble? You don't know what a dribble is unless you have the sequence of frames together and you capture the encoding of those sequence of frames in the same semantic space, the same embedding, right? Jump, dunk, landing, etc. These are motions of a sequence of frames. And so just to kind of hit it home, we have a blog post in the MixPeak blog called Semantic Video Understanding. We break down what a lot of these differences are. And so in this case, frame by frame labeling, that's an onion, that's a knife. But if we wanted to actually use a video understanding model, a video embedding model, it would say, hey, we understand that these sequence of frames parlays into a cutting an onion. So the searches allow you to do contextual-based searches that frame-based searches typically won't understand. Expressions, body language, speech analysis, etc. is really what's unlocked with video understanding. And we actually have a multimodal extractor that is offered in the MixPeak Studio. You can use the multimodal extractor to process your videos or process your images or process your text. Under the hood, the default video embedding model that we use is Vertex's AI multimodal. It's GCP, Google Cloud Platform's Vertex AI multimodal model, and it supports image, video, text. And if we take a look at their documentation, Vertex multimodal embedding docs, we can see it supports what the dimensions it supports are. So as we can see, we can actually select the different embeddings dimensions for text, image, video. You select the start offset / end offset. And this is actually a really interesting point because these are fixed delimiters for chunking a video. And we have a different video in the MixPeak University. We can take a look at that here. Oops. And in here we have chunking strategies, right? And so if we think about what splitting by video is, you can split a video by what they provide, Vertex provides out of the box, which is by an offset seconds, right? Split this video by 10-second intervals. However, what becomes more valuable if you have a lot of sophisticated video content is you want to split the video by, scene, right? The scene transitions, auto shot under the hood, or if you wanted to split by silence, right? Think of splitting by silence as these are different ideas. I'm talking, I pause, I'm talking, right? That is splitting by silence. Or you can do time, that's the most basic one. And think of this as an analogy with text, where if you wanted to split a paragraph up by, or a corpus, a PDF by sentence versus paragraph versus concept, right? And so concept allows us to say, hey, this corpus has different concepts and let's encode these different concepts individually, right? And so that's kind of an analogy that we have here with splitting by scene, right? And so if we go into the actual studio, we can see in this case, we have let's actually break down. We have a bucket. The bucket, when we upload videos into this bucket, we are first splitting up the video by scenes, and we're actually capturing the video embedding of each of those scenes that we've pulled out. And in this case, we're using the Vertex multimodal embedding model. We just have that feature URI that provides the abstraction for us so that we don't have to think about the vector configuration, the inference endpoint, the dimensions, the versions, any of that. So we just have that feature URI, and it's encoding it into a 1408 dimension space, and then the output of that gets sent to this time segments collection. And so we then have all of these collections here. We have the scene segments, time segments, text embeddings, visual style reference, etc. And so all of these are different collections that have been pulled out from this multi-tier processing flow, this object decomposition flow. And so we have the scene segments, and then we'll just build a basic retriever here. And so if we take a look at this basic retriever, we have it just hitting the It's just hitting the vertex multimodal embedding feature URI given the text that we're providing as an input. So if we take a look at the actual stage execution, we say person talking in the video. And so it's doing the feature URI, or it's doing the feature search, and then we have our results. And so these are, again, documents that have been pulled out from that scene segment collection. And we can actually join from the scene segment collection into the time segment collection, or from another collection that we have internally, or some kind of outside source that we've connected. And so that really is the difference between video understanding and image understanding. Just to recap, image understanding is really just, hey, can we encode these frames and maybe treat these frames as a sequence? And then video understanding is, okay, we have these sequence of frames. Can we actually encode them together based off of the contextual similarity of the frames and then return a single embedding? There's trade-offs for both. One can be more computationally intensive, but it depends on the use case that you have. And in the MixPeak multimodal data warehouse, we give you the ability of selecting these different feature extractors and just mapping them to feature URIs so that you can actually test image extractor versus video extractor for your particular use case. And then if you want to migrate your documents over from one to another, it's as simple as pressing a button. My name is Ethan. Again, it's MixPeak. Thanks for watching.